Alright guys, so here we have our new S-Chassis Mega Mantis kit. Just want to clarify, this is hands down my very first time actually welding S-Chassis knuckles. I've done the lowers obviously for the last couple years, but I've actually never welded S-Chassis knuckles, so bear with me on that one. Let's dive into it. You'll get my perspective of, I guess, how I go ahead and make an S-Chassis Mantis kit. So here we have the overlay of all the parts that go into a lower control arm. You've got the body itself, the 3/4 bearing cups. You have the foot to adjust caster and the foot to adjust track width. Pretty simple. Here we have parts for the knuckles. These knuckles are utilizing our optional 350 bearing. So you would use a 350Z wheel bearing instead of a press-on, like a spindle style bearing as a normal 240. So here we go with the lower. There I'm just tacking on the track width foot, I guess you would call that. So I'm doing that just because the lower sits flat on the table, so it's easier to square it up and have it sit all nice and level. A couple tacks. I usually run about 3 tacks on something like that just because there's a lot of weld that goes into it. And then next we'll go ahead and space the arm up because the bearing cup is actually taller than the arm, so we'll offset it equally on both sides by spacing the arm up a hair. And then yeah, we'll weld or tack the bearing cup onto the end of the arm. And then here you can see that I actually hold the cup with my hand while I'm tacking it, just to keep it from pulling with the tack. When a weld is placed and then cools down, it expands and then shrinks and causes things to move or warp. So just to make sure that it's seated in the pocket of the arm, just hold it in place. So there we go. We've got 2/3 of the arm tacked together, and then we'll go ahead and tack on the caster foot. So this is pretty neat on this lower control arm. These ones are new and utilize our on-car adjustability. So instead of a heim joint, a rod end, or a rose joint, or whatever you want to call it, that would have to be taken out of the subframe of the chassis, it actually uses these really nice double adjuster nuts, I think is what we call them. And then that can be cracked loose, or the jam nut can be cracked loose, and then all the adjustment can be made with the double adjuster nut, and no spacers or bolts need to be removed from the chassis. So it makes adjusting on car very easy. All right, so we get that tacked up, and that is a full arm tacked. All right, so there I just went and turned on my fume extractor. So just to be safe, we run fume extractors as often as possible when welding. We're in a closed environment, so to alleviate all the toxic fumes from the welding, especially on something like a bung or a bearing cup that's a machined piece that has machining or cutting fluid on it. The fumes off of those can be pretty painful to inhale, especially for a full 8 or 10 hour shift. So yeah, we'll run the fume extractor. You can see there the fumes are being sucked into the end of that hose, and then it goes into a large filter and then gets pumped back into the air. All right, so you can see there specifically I welded the side of the cup with the groove for the snap ring. I do that because there's actually less material in the wall thickness of the cup because of the snap ring groove. So it heats the material up faster when there's less mass for the heat to get sucked into. So I'll do the snap ring side first every single time, and then I'll flip it over and do the other side. And then there you can see my filler wire got stuck because I didn't pull my gun away from the cup fast enough. And then here you can see I moved directly on to welding the track width double adjuster foot. I ran those ones downhand just because they're not a critical weld structural wise. They're more or less just to get heat into the arm before I go and weld the more critical welds. So that's actually one thing Cam and I have noticed we do subconsciously actually is we not stagger our welds, but we have like a mental order of operations when it comes to welding. So anything that we deem like a non-critical weld or just a small weld or something that's usually like smaller material, we'll do those welds first and allow the heat to sink into the part before we get to the critical part, or the part that has thicker material, so that it's already preheated and we get really good fusion into a thicker piece of material. Like there we have 2 pieces of high strength alloy steel that are both three-quarters of an inch thick, so it requires a lot of energy and heat to actually dig in and penetrate those metals. So we do those. We do the small welds first, and then I'll go ahead and do the larger, the weld at the front of the arm last, because it's already got a ton of heat into it, and that's where most of the strength is required. And it's a very visual weld. It's one of the first things you see on the arm. So the hotter the arm is, typically the flatter the bead lays, and it's just aesthetically pleasing when it lays flat. So with a little head nod, you can see there I'm pretty satisfied. And then we'll go ahead and drop down for the caster double adjuster foot. So on these parts specifically that have pretty large plug welds, because we use tab and slot design a lot for ease of assembly, I will actually run a weave instead of a multi-stringer pass like Cam does. That's just personal preference. I like to weave. I think weaves look great when they're done well. So I do a big weave on that. That gets a lot of heat into the arm really quickly because you're not stopping ever. And then we'll run the small side welds and then wrap around the rest of the arm. There's a really good shot there of all the fumes from the weld being sucked into the extractor. Full disclosure too, this is not my first time welding these lower control arms. I think I've done 3 sets of them now, 2 or 3 sets. This is my 3rd or 4th. But I mean, they weld just like everything else we make, basically. So yeah, it was super easy. Great design, super fast, saves us so much time compared to the other, the old style that's slotted together, and it was 2 pieces of material with 2 bongs and then a separate tension arm. This is a 1-piece lower control arm instead of a lower and a tension arm. It'll be way stronger than the old style. You get the benefit of the on-car adjustment. The welds look great, super strong, yeah. And then you get the nice bump stop there by the cup, and it's a uniball cup instead of a Heim joint. So everything about this arm, much better. And then here we have a lower control arm that Cam had welded, and I'm just assembling it. Actually, I'm making a tension arm off of the lower. This isn't how we weld the tension arms. Typically, we'd do them in bulk, but this was just for demonstration. I just had to make one so we can lay out the old style 2-piece lower next to the new style 1-piece lower, just as a demonstration. So there we go. So you alleviate one whole arm. You now have the on-car benefit, way stronger material. Yeah, everything about this arm is much superior. All right, moving on to the knuckle. So here I'm just cleaning up any of the, what is it? I guess just the mill scale and anything from the laser cut. Any rough edges or oxidized material. Laser likes to leave a really rough edge, so I'm taking all that down. Those were sandblasted, so I was just cleaning those up. So when you MIG weld sandblasted parts, there's actually a little bit of the sand or whatever the media is that gets embedded in the surface of the material you're welding. MIG welding already has a very high silica content in the filler wire, at least the filler wire we're using. Added on with the sand deposits on the surface of the material, which also includes a lot of silica. You get very high silica deposits on your weld. Not that that's a bad thing, but I just like to knock the surface off just to kind of get any sand out of the pores of the material. That's just a personal preference. Obviously, welding sandblasted parts, you can't really cry too much about it. It's a luxury for sure. So here we go. We're tacking the first part onto the knuckle face. So that would be the top shear plate, I guess we would call it. All of our joints, tie rods, lower control arm, ball joints or whatever, we use double shear instead of a single shear like an OE would use, and it's much stronger, so it captures the bearing on both sides and sandwiches it. So that would be the top plate, and I'm just tacking it in first. So that one gets welded on first just because of ease of access, and it gets used as a point of reference for a lot of the other parts on the knuckle. And then this knuckle actually uses really nice capture nut design. So we'll go ahead and square that up with the face of the knuckle. You can see there also right beside the FDF logo, there's a hole cut in the front of the face, and it actually gets threaded. So this arm uses a bolt as a bump stop on the knuckle instead of a plate on the knuckle, and a bolt in the lower, which is nice because it alleviates having to weld a bump stop to the knuckle, so there's less parts to it. So there we go, and we'll weld the knuckle back, or the shock mount part, to the knuckle face itself. And then here are the two side plates that join the top shear plate to the knuckle back. And then this is actually what houses the nut for the lower control arm ball joint or bearing cup, so that you can actually tighten or loosen the 1/2-20 bolt that goes in it without having to put a wrench on the nut itself. It gets captured between those two plates. There you can see it. It just didn't fit great, so I'm just gonna try to square it up here by hammering it into place a little bit, just to get it as square as possible. And there you can see the capture nut design. Those two plates prevent the nut from spinning. So yeah, I'll just get it all squared up as best I can, give it another tack. Again, first time making an S chassis knuckle, I literally had no idea what I was doing. I've just seen Cam make them for nearly 3 years, and it just looked like the right thing to do. Also, shout out those snap-on pliers I have. They're fantastic. I would completely recommend everybody go buy a pair. They're great. So yeah, you could see there I did the open corner welds first, and then I went and did the plug welds. This is just because open corner welds, when they get super hot, they tend to bleed over the edges, and you get kind of like an undercut type of deal where the weld bleeds over the edges or it blows through the corner of the joint. So I try to do all my open corners on anything that has them first. Again, this is just like with the lower, you have like the order of operations when you're doing welding with multiple thickness of parts and multiple different joints. So it's just something that comes with skill over time. So yeah, I'll do the open corners first, and then I did the plug welds, and the plug welds get a lot of heat into the arm before I go and do the main structural welds. They're also very visually aesthetic and pleasing. I did those, and then I did the inside fillet welds. I did the welds on the knuckle back. So because the knuckle back and the knuckle face itself are the two thickest pieces of material, one being 3/8 and the other being 3/4. They obviously absorb a lot of heat, and a lot of heat sinks into them, so I'll do those welds last and let the other welds actually heat the part up so that I don't need to go and change my welding parameters on my machine. I can weld the entire thing on one setting. Lastly, I will weld the bottom shear plate on, and this is strictly just for access to the rest of the knuckle. Once you weld the bottom shear plate on, it makes it tough to get the one fillet weld for the top shear plate. And then yeah, it also requires a lot less heat just because it's on the bottom of the knuckle. It's like an open corner and then a fillet all in one. So yeah, we'll usually let the knuckle cool down a little bit before going to do the bottom shear plate weld, but on this case we were doing it on a camera, so I just sent it. And then here we have, here I am installing the bearing spacer. So that's the part that houses the bolt-on 350Z wheel bearing instead of a spindle that would get a press-on wheel bearing. So those actually get water jet cut blanks in-house, and then Dylan machines them on our Haas mill. So they fit great. And then that's it. That's the whole knuckle. That was my very first time welding an S chassis knuckle. As of right now, they haven't been released yet. There's a couple out there floating around that we've sent out to some guys. Feedback's been great on them, so I believe we were filming this video actually as a means to release the kit to the public. So yeah, be super stoked that this one's coming out. This is gonna be a game changer. I don't think anybody else offers anything like this. You would get the reputation of FDF with our strength and quality, as well as the ease of installation and the ease of maintenance with the on-car adjustability. It's absolutely going to change the game for the S chassis world. So yeah, be super stoked on this. I know we all are, and that's it.